Imagine going to space in a rocket and landing like a plane on a runway. The Space Shuttle was an icon of its era, flying for 30 years from 1981 to 2011. Officially, it was known as the Space Transportation System, or STS. 6 were built. The orbiters Columbia, Challenger, Discovery, Atlantis, and Endeavour were all space-capable. The first orbiter built was the Enterprise, which was used for approach and landing testing. It was originally named the Constitution, but fans of Star Trek petitioned to have its name changed to Enterprise. The Space Shuttle was essentially a cargo ship, capable of putting 27,500 kilograms of payload into low Earth orbit. For perspective, an average city bus weighs around 13,500 kilograms. The Space Shuttle could send the weight of 2 city buses into orbit. During its 30-year career, it was responsible for launching some pretty awe-inspiring spacecrafts. It carried several space probes destined to explore our solar system: Galileo to Jupiter, Magellan to Venus, and Ulysses to study the Sun. But perhaps more well-known, it launched the beloved Hubble Space Telescope, allowing us to see further than ever before. Its first mission was STS-1 on April 12, 1981, using the orbiter Columbia. It launched mission commander John Young and pilot Robert Crippen on a 3-day mission to test the shuttle's orbital capabilities. Towards its later years, the Space Shuttle's primary mission was to complete the International Space Station, launching the U.S. orbital segment over the course of 13 years, from 1998 to 2011. Composed of 4 major components, the shuttle included the orbiter, built by North American Rockwell, an external fuel tank built by Martin Marietta, and 2 solid rocket boosters built by Morton Thiokol. The boosters would separate from the spacecraft and parachute to the sea for recovery and refurbishment. The orbiter carried both crew and cargo. It was capable of launching vertically and landing on a runway as a glider. It was built mostly out of aluminum alloy, with some elements using titanium alloy. Its distinctive shape was the result of extensive aerodynamic testing, which was defined by 2 large delta wings. On launch, the orbiter used 3 Space Shuttle main engines, or SSMEs, which were RS-25 engines built by Rocketdyne. Each engine produced 1,859 kilonewtons of thrust and consumed liquid hydrogen and liquid oxygen at cryogenic temperatures. This fuel was drawn from the attached external fuel tank. In addition to the main engines, 2 orbital maneuvering systems, or OMS thrusters, were mounted as pods in the upper rear part of the orbiter. These were sufficient for orbital maneuvers. For more fine control in the vacuum of space, the Space Shuttle's Reaction Control System, or RCS, was a collection of 44 small liquid-fueled thrusters, which were controlled by the crew. It utilized a highly toxic hypergolic fuel, which gave instantaneous ignition, ideal for responsive control, but terrible if you breathe it. The first 4 shuttle missions included operational ejection seats on the orbiter Columbia. These were eventually removed during STS-61C, Columbia's 7th mission. Its payload bay was the largest portion of the orbiter. External access was provided by 2 large hinged doors which swung outward and also served as radiators to reduce vehicle heating on orbit. Within the payload bay, the shuttle's remote manipulator system, more commonly known as Canadarm, was a series of robotic arms that extended along the inner edge of the bay. It allowed the crew to manipulate payloads without requiring a spacewalk. Special materials were developed into the thermal protection system by Rockwell Space Systems. Unlike previous spacecraft which used a blade of heat shields that burned away during re-entry, the orbiter utilized lightweight reusable components. The nose cap and wing leading edges were made of reinforced carbon-carbon designed to endure temperatures exceeding 1,260 degrees Celsius. For context, the aluminum alloy which the shuttle was primarily built of liquefied at 638 degrees Celsius, a fair bit below the limit of the thermal protection system. The underside of the orbiter utilized high-temperature reusable surface insulation, or HRSI tiles. These tiles, though lightweight, were also incredibly fragile and could be crushed by hand. The orbiter's landing gear could not be retracted. This was to save weight. Its operation was so crucial it could only be manually operated and was lowered by triple redundant hydraulics. If this system failed, it could be lowered using pyrotechnic charges and locked in place with springs. The Space Shuttle program was extraordinarily expensive. It was designed initially to be a cost-saving alternative to conventional rockets. It has been estimated to cost $221 billion. Initial development estimates claimed it would have cost $558 per pound to launch to orbit in 1972. Actual costs were $27,000 per pound. Perhaps more eye-watering was a 1982 estimate of $260 million per launch. The entire program would cost $1.5 billion per launch. Barring astronomical costs, no pun intended, the Space Shuttle program was entering its 30th year in 2011. Its retirement was announced in January of 2004, and its mission was primarily to assemble the International Space Station and complete the final service mission to the Hubble Space Telescope. 2 space shuttles were destroyed, Challenger in 1986 and Columbia in 2003. The Challenger disaster occurred on January 28, 1986, when the failure of an O-ring seal located between segments of a solid rocket booster failed. Hot gases escaped and burned through the external tank containing highly explosive propellant, destroying the orbiter and killing its 7 crew. In a NASA analysis, which looked at risk factors for failure of flights before the Challenger, it was determined that there was a 1 in 10 chance of losing a shuttle and its crew. Some 17 years later, on February 1, 2003, Columbia was destroyed during re-entry. It was found that the damage to the heat-resistant, carbon-carbon leading edge of the wing caused by falling foam insulation from the external tank resulted in the compromised integrity of the orbiter. The combination of exorbitant costs, aging hardware, high risk factors, and poor safety management led to the retirement of the Space Shuttle. An icon of its era, it will be remembered for launching generation-defining space probes, telescopes, and space stations, paving the way for scientific discoveries well beyond its lifetime.